Hello everyone, welcome to this session on Azure Databricks. Azure Databricks is basically a Apache Spark based big data analytics service by Microsoft Azure. Today in this session, we are basically going to understand how we can use this service to solve data science and data engineering problems. But before we start the video, guys, if you haven't already, please subscribe to the IntelliPath channel and also click on that bell icon to never miss out on any updates from us. So now let's go ahead and start off with the agenda. Alright guys, so first of all, we'll go ahead and understand what is Azure Databricks and then move on to discuss why do we actually need it. After that, we're going to talk about how does Azure Databricks basically work and then talk about the various Databricks utilities which are out there which you can use in order to implement your big data workloads. Finally, we're going to talk about how you can integrate Azure Databricks with Azure Blob Storage and implement a project that we are going to go ahead and show you in this session. So guys, this is the agenda for this session. I hope it's clear to you. Now let's go ahead and start off with the first topic, which is what is Azure Databricks?
What is Azure Databricks? Before we actually understand what Azure Databricks is, we need to understand what Databricks is because they are two separate entities. Databricks was founded by the original creators of Apache Spark. It was developed as a web-based platform for implementing Apache Spark basically. So normally you would implement Apache Spark with a locally hosted cluster. With the Databricks software, you get the option of interacting with your Spark framework using a web-based UI. It provides automated cluster management and IPython styled notebooks. So the best thing about Databricks is that the cluster management is automated completely. So it's completely software based. So you absolutely do not need to manage any aspect of the cluster manually. All of it is automated. And on top of that, you get IPython style notebooks. So if you're coming from a data science or data analytics background, so you must be familiar with Jupyter notebooks. So that is what essentially IPython notebooks are. So you get them pre-installed with Databricks. So you have your cluster, you have your notebooks pre-installed, you launch your notebook on top of the cluster. Whatever code you execute in that notebook will utilize the full functionality of the cluster that you have if you're using the Spark libraries. So the two features we need to focus on when talking about Databricks would include automated cluster management and coding notebooks. So now that we know what Databricks is, we can move on to what Azure Databricks is. So when we move Databricks to a cloud service, for instance, Microsoft Azure, it's called Azure Databricks. It is the jointly developed data and AI cloud service from Microsoft and Databricks for data analytics, data science, data engineering, and machine learning. So essentially all activities related to data, you can use Azure Databricks for that, especially if you're dealing with big data. So we can see when we combine Databricks with the Microsoft cloud service, which is Microsoft Azure, we get our Azure Databricks service. So if we look at the architecture that is followed by Azure Databricks, it is a cloud service. So it lets you set up and use a cluster of Azure instances or Azure virtual machines, and all of these virtual machines are combined together. They have Apache Spark installed on top of them, and it functions in a way similar to your big data cluster, where following a master worker nodal dynamic. Similar to how you would install your local Hadoop or Spark cluster or your big data cluster. So if we look at the diagram now, we can see that on the left hand side, right over here, we have our remote site client. This is the device that we're using to access our Azure Databricks service. Then we initiate our remote access to our Azure Databricks console, say your web browser. And then that's all we need to do. Here is where we will be basically interacting with, right? We wouldn't be able to see the actual servers. We wouldn't be dealing with any of the complexities of maintaining the actual instances that we are running for our cluster, the nodes that we are running for our cluster. We don't need to deal with that. Azure Databricks manages all of that for us. So once we send our commands to our Azure Databricks service, it will send those commands to the cluster that we have for the Spark cluster that we have, and we will get our use cases resolved. And when dealing with cloud services, the main advantage is abstraction. So we do not need to deal with any of the complexities of the cluster. So that is why we have the invisible icon over here, because we're not dealing with the cluster directly. So now let us move on to why Azure Databricks. Why do we use Azure Databricks as a service as opposed to any other means of analyzing data or big data? So since Azure Databricks is a cloud-based service, a Microsoft managed cloud-based service at that, it already has several advantages over traditional Spark clusters, which means that locally hosted Spark clusters or locally hosted Databricks clusters, when we are using Azure Databricks, we get several advantages over them. So let us look at some of the benefits that we get when using Azure Databricks. So firstly, an optimized Spark engine. So what does this mean? Data processing with auto scaling and Spark optimized for up to 50x performance gains. So 50 times performance gains, right? So say if you're hosting a local Spark cluster in your office space or in your server room, you don't have such complex features as auto scaling or optimization of your Spark engine. You don't have those features automatically available to you. You have to manually adjust a lot of things. You have to manually install or remove nodes from your cluster. So when you're dealing with a Microsoft paid service, when you're dealing with a Microsoft cloud service, you get auto scaling features with it. So depending on the use case that you have, depending on the workload that you currently are dealing with, Microsoft has the option to scale up your cluster or scale down your cluster. So it helps you reduce costs and it optimizes the cluster requirements, the cluster hardware settings according to the complexity of the job that you have at hand. Then machine learning. So there are pre-configured environments with frameworks such as PyTorch, TensorFlow, and scikit-learn already installed. So we will get into this when we get into the Databricks utilities. But basically the point is all of these libraries such as PyTorch, TensorFlow, and Scikit, we can get pretty easily when we're using Databricks instead of having to manually download those libraries and installing them into our environment. And then MLflow. Track and share experiments, reproduce runs, and manage models collaboratively from a central repository. So MLflow is a feature provided to you by Microsoft Azure, which helps you basically collaborate with your teammates that you may have in your data analytics team or your data science team. You can share your experiments. You can try to reproduce the runs with the models that have been created. You can manage the models that you've created, and you can manage them from a central repository. So you can push and pull all of the models that you've created and deposit them into a central repository so that your teammates can access them as well. Then one of the best features that you get with using Databricks in general, not just Azure Databricks, is choice of language. So especially in Microsoft Azure Databricks, when you're launching a notebook, once you've set up the cluster, once you're launching the notebook, you get an option to start your notebook in the preferred language that you would require, right? So you can start up the notebook in Scala or Spark SQL or .NET. So whether you use serverless or provisioned compute resources, you're able to do that. So the best thing about this is that you can get started with your use case pretty easily. You are not dealing with a lot of setup over here. You're not dealing with a lot of administrative job right now. You're only dealing with the use case. You're only dealing with analyzing data, processing data, visualizing data, or whatever your use case may be. So the next feature would include collaborative notebooks. So quickly access and explore data. So notebooks obviously can be opened by others as well. You can simply share the notebooks. The other people, the other teammates can look at your code. They can execute that code. They can make changes to that code. They can make modifications better, efficiently optimize the code. So all of this is basically accessible in a cloud environment pretty easily. You don't have to manually share anything. So quickly access and explore data, find and share new insights, and build models collaboratively with the languages and tools of your choice. Delta Lake. So Microsoft Azure gives you the service of Delta Lake. So you can bring data reliability and scalability to your existing data lake with an open source transactional storage layer designed for the full data lifecycle. So when you're using your Databricks with Delta Lake, you can have your data already indexed for you for faster transactions. integration with other Azure services. So the best thing about cloud services is that there are other cloud services for various other things as well. So this is the case for AWS, this is the case for Google Cloud, and this is the case for Microsoft Azure as well. So when you're creating your Azure Databricks instance, when you're creating your cluster and your notebook, you can also integrate with other Azure services. So these could include Azure Data Factory, Azure Data Lake Storage, as we discussed before, Azure Machine Learning, if we are dealing with complex machine learning models, and Power BI, if we are dealing with business intelligence. Other features would include interactive workspaces, so the easy and seamless coordination between data analysts, data scientists, data engineers, and business analysts. So people coming from a data background, a coding background, or even from a business analyst background can have a smooth collaboration between them because these workspaces are interactive and easily accessible by one another, and enterprise grade security. So another good thing about cloud services is that you get security by default, and these companies, they are legally liable for any data breach or data loss or any attack by any attacker, right? So it is their job because we're paying them to protect our data. So we get enterprise grade security already available with our Microsoft Azure Databricks workspace. The native security provided by Microsoft Azure ensures protection of data within storage services and private workspaces. So we already get that regardless of we're using a Microsoft Azure storage service or if we are using workspaces in Databricks itself, we can be absolutely sure of enterprise grade security and production ready. So you can easily run, you can easily implement and monitor your heavy data oriented jobs when you're running big data jobs on your notebook or your cluster. And you can get the job related statistics that you're currently running very easily as well. Because a cloud service such as Databricks, Microsoft Azure Databricks helps you monitor that. How does Azure Databricks work? So using Azure Databricks is actually not that hard because you only have to deal with a few UI elements that you get with Microsoft Azure on the default. You have to enter some details, and according to that, your cluster or workspace will be started. So it's pretty easy, and we'll see that when we reach the hands-on section. But before we actually get to the hands-on section, we need to deal with Databricks utilities first. So this is a Databricks exclusive utility set. So this is basically the set of commands that you already get pre-installed with your Databricks setup. So outside of your normal Python Spark or Scala Spark setup that you have these external commands in order to install libraries or packages, or in order for you to integrate various services that you may have. So say you have a file available on your data storage service in your Microsoft Azure, and you need to import that file. So you cannot directly do that when you're using Python with Spark. So you need some external element attached to it. So that is where dbutils comes in. So dbutils help us perform a variety of powerful tasks, which include efficient object storage, chaining notebooks together. So if you have multiple IPython notebooks, you can chain them all together and perform their functionalities in a sequence. And it also helps you to work with secrets. So these secrets are with regards to authentication. These could be passwords, certificates, or keys in general, like public and private key pairs. So all of those things you can basically configure into your dbutils in order for you to authenticate into another Microsoft Azure service, and then you can essentially import your data from there, which we will see in our hands-on. So one thing to note over here is that dbutils are not supported outside notebooks. So you can only use dbutils when you've launched a Python or a Scala notebook with your cluster that you've created, with your Spark cluster that you've created. So dbutils are not supported outside of notebooks. Integrating Azure Databricks with Azure Blob Storage. So Azure Blob Storage and Azure Databricks are both services provided to you by Microsoft Azure. So these are two separate services, but as long as you're using the same resource group, you should be able to combine these two. So why would you need to combine these two? Let us see that. Microsoft Azure provides a multitude of services. It is often beneficial to combine multiple services together to approach your use case. So basically, the advantage of combining multiple services together is that you don't need to engage your local hardware into anything. Like currently, I'm using my laptop to look over this presentation. So I want to keep my laptop clean, or maybe my laptop is of a lower hardware configuration. Maybe I don't have enough disk space, right? So in that case, I would want to use the cloud services to handle all of my use cases. So I want to use the cloud service to handle my big data storage needs. So I would store it into an Azure service that I have. I need the cloud service to process my big data. So for that, I'll use Azure Databricks. So all of my use cases are being solved by the online services provided to me by Microsoft Azure. So say if you want to integrate two services such as Databricks and Blob Storage, then this is the workflow or architecture for that. So you're the user, you have your device present to you, available to you. And what you'll do basically is you'll interact with a coding notebook. Right. So this coding notebook is a IPython or a Jupyter notebook that your Azure Databricks will create for you. So the way this works is you interact with your Azure Databricks console. You launch your coding notebook. You type some commands into your coding notebook. The coding notebook commands are then sent to the Databricks service, and the Databricks service sends those commands to your Azure cluster. Right. So the cluster that you've created. After you've created your Databricks workspace, and you've created this notebook on top of that cluster. So those commands go into the cluster. Then, depending on the authentication provided to the cluster with regards to your Blob Storage account, the authentication details are sent to the Blob Storage service. The data is fetched from the desired directory. It is brought back inside the cluster. The data is processed, and you see your output on your coding notebook. Now, this works twofold also. So you can directly upload your data to your Microsoft Azure service. Once you've uploaded that data over there, you can then access your coding notebook and access that data from your Azure Databricks service, and then process it and then get your results. And from then on, you can also store the output that you've created back into your Blob Storage space. So all of this is very easily handled and seamlessly integrated together. So now that we've discussed the architecture, let us look at how to actually implement this with our hands-on section. So now that we've gone through the introduction to Azure Databricks, we will now be heading over to the hands-on section of things, where we'll be integrating Azure Databricks with another Microsoft Azure service, which is Azure Blob Storage. So let us get to it. Simply go to the Azure Databricks service on your Azure portal, click on it, and then simply click on Add. So once you've clicked on Add, you'll get a lot of options. So the subscription will be pay as you go. Create a new resource group as you want. Remember the name, just be sure that you remember the name. So I can type in something like Databricks resource group, and you can give anything that you want. But for now, let's just use the Databricks practice resource group. So this is a resource group that has already been created. And then you can name your workspace anything. So let us call this Databricks workspace 1, and select the location that you would prefer. So it's generally a practice to select the location that is the closest to you. So just select West India. And then we can simply decide the pricing tier. So in the pricing tier, go for the trial one, because you're going to be practicing. You're not going to be actually implementing any organizational needs. So go for the trial version, and then click on review and create. Just look at everything that you've selected, see if it's right, and then click on create. So once you've done that and the deployment is underway, you will have to wait up until your deployment is actually ready for you to be able to go to your resource and do what you have to do. And once your deployment is complete, you can go to your resource and launch your workspace that you require. So you can click on launch workspace from here, and then you can essentially log into the Databricks portal. It will sign you in. And from there on, you have these familiar options. So you can create a cluster, create a notebook, and essentially get started with your Databricks journey. In Databricks, I was confused with an AWS service. In Databricks, we don't actually use the HDFS. We're using DBFS. So it's exact same thing as HDFS, except DBFS has this network element to it, which helps us combine cloud instances. So Databricks file system. In theory, in practice, it works in the same way as the HDFS.
So there is no Hadoop. Hadoop is not coming into this picture now.
Hadoop is not coming. It's not required.
So then, how this is happening?
So
fault tolerance
if
and
in the Spark practice that you may have done in the past, the theoretical information is Spark is not dependent on Hadoop.
no,
Even though
what I have learned is Spark can use either Mesos or Hadoop. Only two are allowed. Two you can use. So
no,
it has
that
to
is
be
not
one
a
of them. I
Spark
think.
can use any distributed file system. Spark doesn't have a limitation to Mesos and Hadoop. It can use any distributed
Oh,
file system.
okay. Is it okay? Okay.
There's no. I think there's not a compatibility issue. That is what Spark. That is why Spark is flexible. It doesn't have a compatibility issue. You can use the local file system as well. You can use
Yeah,
an online file system as well. You can use a distributed file system as well. So
yeah.
all of those things are possible with Apache Spark. I'm sure you've used local files when you were practicing with Spark.
Yeah, that's correct. But in actual practice, it has to be this application has to be routed to all nodes, right? That has to be
Yeah,
done
yeah,
either through Mesos or Hadoop. That's what I
yeah.
thought. Okay.
Yeah. So this is going to be just that way. When once we ingest the data, it is automatically replicated across depending on the configuration. It's automatically replicated when the data is ingested. It's replicated across, divided into parts, replicated across the nodes,
Okay.
and then we process it with our commands. So our deployment is complete. So the next thing you would do is click on go to resource, right? So now we will launch our service. So for that, click on launch workspace. I think there's one other step we have to do. So this will log us into the Azure Databricks platform. So this is the very conveniently and well wrapped around terminal that you get. So a lot of things might seem familiar here, right? So we have these options. We can create a new notebook. So we cannot actually do that if we haven't created a cluster because we need something to run our notebook on, right? So the
Yeah.
first thing that you would do is create a new cluster. And now we can specify things. So let us just call this Databricks session. This is what the cluster is. The cluster mode could be high concurrency. So high concurrency happens when a lot of people are using the cluster at the same time. So that a lot of jobs could the scheduling is optimized in high concurrency where the jobs are scheduled in the manner of resources. In standard, when you're only using it for practice purposes, you would go with standard. Or jobs that are not that frequent. If your company doesn't have to do frequent jobs, then it would use the standard mode. The pool is keep a defined number of ready instances on standby to reduce cluster startup time. All right. So this is another feature. I haven't used this before. I think this is.
It's just a standby. Yeah. To reduce cluster startup time.
So
Something
it'll
it's always ready.
preemptively start up the services. Right. We can decide the Scala and Spark version that we want. So there are a lot of options. Right now we're going to use the stable one, which is 7.2. And then we can also enable auto scaling or disable auto scaling. So as I discussed in the PPT, in the minimum workers we can specify and the maximum workers we can specify. So at the minimum and in the minimum, when it's doing the most least requirement requiring job, then it will use the minimum number, right? And when the workload gets really, really high, so it will get somewhere between 2 and 8. We can specify when you increase this to anything we want, right? Obviously, the price would increase as well. You are actually using 17. And if you are using it for practice, you don't need to enable auto scaling as well. You disable that and you specify one work.
Okay.
Right? So now you don't have to pay literally anything. Terminate it after dash minutes of inactivity. So if you're not running any commands on it and you've somehow forgotten that you've let that resource run, you've forgotten, you've logged out and you went somewhere else, right? So if you don't want to be charged for that, charge for inactivity, because even though Azure will not cost you anything when you're not using it, what will happen is there is a certain amount of storage space in every instance that you're creating in the cluster. So that storage space is not entirely free. There's a nominal cost attached to it, but it's still there. So if you're using one worker, it's negligible. But if you have 150 workers, and all of that will add up, right? So we can simply provide the minutes of inactivity, after which it will automatically terminate. The cluster will automatically terminate after that. So I'll just put it to something like 60 right now. I'll just put it to 120. I'm going to disable it anyway. So let me do that. And we can choose the instance type. So there are a lot of like in AWS, there are a lot of instance types in Azure as well. So these are the instance type for the worker, what you want for the worker, and the driver is the master
So
basically.
that is per worker, so much memory is allocated, is it?
Yeah. So memory means RAM, and this
Yeah.
is how much RAM it has, how many cores it has, right? So you get that.
Okay.
So let us get with the default, and the driver is let us same as worker because it's the minimum, bare minimum, the weakest possible instance we're using, right? But you can obviously, if you have a higher workload, you can use higher instances with high memory. So it goes 56 GBs up to that much RAM. You click more, and there are more 256 GBs. And then in the region that we are operating in, we don't have these available in the West India region.
Oh,
But
okay, okay.
you can opt for these if you choose another region because we don't have that architecture in the Indian server house
Okay,
for
okay, okay.
Microsoft, whatever it has in Mumbai.
Mhm.
Let us now create it. So you can click on create cluster. Let me just check once. Yeah, create it. So this will take some time to deploy as well.
Mhm.
So we'll wait for that.
I
So
got
it's
you.
currently pending because it's being set up. The nodes are being initialized. Spark is being installed on those nodes. Those nodes are being added in the same cluster, right? So all of that is happening automatically on its own in the background in the servers of Microsoft Azure. And it'll once it has created, once it has reserved those resources and has installed Spark on it, then the state will be I think running already, and then we can use our cluster for our workloads. So we'll wait for that.
So this pay as you go means it's not like monthly. There is no subscription charge or anything. It depends on how
No,
much
no.
you use. That's all.
Use, yes,
Like,
yes. So workload depends on the workload, depends on the number of nodes you're using, depends on the quantity of storage you've reserved for your cluster. And that is one of the key advantages as well, right? For using
yeah,
cloud
yeah, yeah.
services. Say if you're a business owner and you have big data needs, right? So
Yeah, yeah.
you have two options. If you use the cloud services, you only pay for the amount of usage that you have. But if you're owning some hardware locally in your own office,
Mhm.
then you have to if you've rented it, if you bought it, you have to pay for the entire thing, and then you have to pay for
Yeah.
the electricity cost, you have to pay for maintenance, you have to pay a server administrator to maintain that server, to add any new cluster, add any new devices to it, add any new hardware to it, upgrade it, and everything. So this all of this is managed by Azure in this case.
Yeah, yeah,
So
yeah.
it's now in running state, and there are two nodes. The
Two
first is
nodes.
the driver node and the worker node, right?
Mhm.
All right. So we can now simply go to the Azure Databricks terminal, and here is a new notebook option, right? We can click on
Mhm.
that, and then it'll ask us which cluster we want to use. We will use the cluster that we've just created.
Yeah, yeah. Mhm.
So it's there in the options, and we can select the language that we want to start our notebook in. So I'll select Scala,
Okay.
right? And then we can simply call this notebook anything. Let us call this Databricks notebook and click on create. So this will start almost immediately, right?
Oh, it looks like Jupyter
Because
notebook.
yeah, it's just like a
Yeah.
Jupyter notebook. You have to press
Mhm.
shift and enter to run every command, and then you can add new code blocks and all that, right?
Okay, okay. Mhm.
So now what we will do, I will tell you how to upload files and integrate this notebook with a storage platform like an Azure service, a different Azure service. So we're going to be using Azure Blob Storage. So this is like Amazon S3. It provides a storage service to you. Azure also
Oh,
provides you with a storage service, which is the Azure storage accounts, and you can create data containers on it, and then you can use those in your various Azure service activities. Not just with Databricks, you can use it with other Azure services that use it as well. So let us go to the Azure dashboard once again because it is not part of Databricks. What I'm going to be doing right now, it's not from here. Actually, there's a UI element for the go to meeting thing, so that is why I'm not able to see my tabs. Yeah, so this will open that up. Yeah, I'm back in my portal, right, from where I can
okay.
launch all of the services. So this is storage accounts. You will click on that because you will be adding some. You'll be requiring to store something, right? So
Mhm.
these are already created by my peers and everything. So these are some are big storages, some are blob storages. So depending on whatever everybody is doing, say they create that, and you can create your own. Click on add. So as I was discussing before, the pay as you go remains as it is because that's
Yeah,
the
yeah.
only option. And now you don't have to deal with any permission issues because once you click on drop down the menu of resource group, you can just
Yeah, yeah.
find the resource that you've created. So all of the permissions are already intertwined, right? You don't have to go and allow, you don't have to create some sort of IAM role like you would have to do in AWS to integrate
Yeah,
services.
yeah.
So Databricks resource, I think it was that. And simply check it over here. Just a moment. So resource group, Databricks practice. It's not, I think it's not Databricks, whatever it was.
Okay.
Databricks practice. Yeah, it is this one.
That one. Yeah. Okay.
So you can name this anything you would like. Let's call this Databricks session storage. And the location, it is better if you keep the location same
Same.
for latency reasons. You can keep it different if you want, but it will take a longer time to say if you're analyzing a lot of data, right, which requires immediate, precise, low latency transfers immediately. Then
It should be the
having
same
something in
location.
the something being in the US and something being in India, it will take about 2 seconds to actually request and respond. So
Latency will be there.
yeah. So that is not a good case.
Yeah,
And account guide, you can choose anything. So we are going to be using general purpose V2. The payment is not an issue over here because it entirely depends on how much data you're actually uploading, right? So right now I'm just going to be uploading a megabyte of data. It's not going to cost me anything. I can use the V2. And just put it a replication, you can put it to locally redundant. So the difference between geo redundant and locally redundant is that the geo redundant, the data is replicated across regions. So in West Mumbai, there will be one instance of that data. And in the US region, there would be other and whatnot. So that is something that storage accounts would manage automatically. But in locally redundant, what will happen is it will, for our use case, because we're not dealing with any data that is that we're fearing to lose, that would cost us money if we lose it. We don't need that sort of that sort of a backup or that sort of a use case where from multiple places people are using the storage service. That is not the case in our case. So we'll use locally redundant, where the data is replicated but in the same server space. Like it will be replicated 3 times in Mumbai itself.
Yeah.
So we're going to be using that. And the access tier, you can simply look at it. So the account access tier is the default tier that is inferred by any blob without any explicitly set tier. The hot access tier is ideally for frequently accessed data, and the cold is for when you don't have to access that data frequently. So not a pricing issue in our case for our use case. So let us click on create and review. So review all of the details. I think they are right. West India database storage, don't you think? And then we can click on create. So this will create our storage account. Now we have to create a container within our account. So let us wait for the deployment.
So those settings we can change if we want, is it?
Yes.
For example, that hot to cool we can make if we want.
Yeah. So say that your organization deals with the data analytics, but it does not deal with it in real time. Like it doesn't want it like on a minute-to-minute basis, right? So you want it on a routine basis. They say your tool, whatever you assign, whatever your code is, it checks for the data every 6 hours, right? So your storage service could simply be a cool storage service where if it's being checked every 6 hours, so I think there's some sort of configuration assigned to it. The request and responses pricing is adjusted according to that. So the deployment is complete, and we can go to the resource now. So all of the permissions are automatically managed just by using the same resource groups. We don't have to worry about that. And now we can create our table. Not a table, but our container where we'll store the data similar to how we would store it in Amazon S3. So click on containers when you've opened up the resource. And now we can simply click on plus container. So add a new container. And then we can name this container anything we want. So let us call this Spark assignment. And let's click on create. So we have it over here, right? So let's go back to the presentation for once and get over these topics a little quick. So we have Databricks utilities. So these are, everything is virtually the same. And you're using Databricks and Spark. Everything is essentially the same. The only new thing that is there is Databricks utilities. So these are additional utilities. That they are not exactly libraries. These are utilities that are provided to you by Databricks, not by Microsoft. It's not a Microsoft thing. This is just a Databricks thing, right? So it is basically a utility to operate within a cloud environment. right? So help us perform a variety of powerful tasks that include efficient object storage, chaining notebooks together. So you have commands in various notebooks that you want to chain together for your particular use case. You can do that. So all of this is provided to you. As you can see in on the bottom, we have commands, right? Like install PyPy torch, install PyPy scikit-learn. So you simply have to write that one command. It will install it within your workspace. So since this is not, you will not open up Apache Spark. You will not write a Spark code and type installation commands, right? You will not do that. You generally write what you have to implement for the data, right? So
Yeah.
you definitely need something that would help you configure your workspace, right? So that is what dbutils is used for.
Mm-hmm.
I hope you get the idea. So these are
Yeah.
not supported outside notebooks. You cannot use it with the putty, right? Obviously, because since you've used Spark with putty or anything, you would have not noticed that there's something called dbutils. This is specifically
Yeah.
for notebooks.
Yeah.
So the dbutils are available on 3 platforms: Python, Scala, and R.
Mm-hmm.
The difference in Python and Scala, if you create Python and Scala notebooks, the advantage is that you would be able to use dbutils file system utility as well, where you can manipulate the file system of your cluster nodes. With R, dbutils does not come with a file system manipulator. You can only use the other features like installing particular packages and whatnot. R is a limited language, not
Yeah.
much of a development language. Let us integrate it now. Go back to the web page. Right. So now we have our container created. So we can simply click on this container, right? And we can click on upload. So this would open up my Windows file system. I can select a file that I want to upload. Let me go to the desktop. So I have this file yellow.csv already there. It's a CSV file. I simply add it to my files, and then I click on upload. So it's a 1.44 MB file, so it uploaded instantly, right? But you can upload larger files as well, but it will cost you a lot. If you're uploading extremely large amounts of files, right? It will cost you more. So that is how the pricing works here. 1.4 MB comes in free tier; it does not cost you anything.
Okay.
So we have this, right? Now we need to integrate both of these. We have our data in place and we have our notebook in place, right? We need to integrate now. So let's go back to the notebook. You see, yeah. So we're back at the notebook. So it takes.
One small thing. I just want to know the hierarchy. So the workspace is on the top level, is it? Under workspace container comes, or how it is? Or
Okay. So let
something
me.
wrong.
Okay. So this is how it works, right? Yeah. So you have your Azure terminal over here. This is your Azure
Mm-hmm.
terminal or Azure service, basically Databricks service. Let's call this Databricks service. And on the other hand, you have your blob storage or container. Like this is your storage container.
Mm-hmm.
Actually, I have the diagram for it. Just a moment, I forgot about it. I made this. Okay, so this is how it works. I apologize. I was actually making it on paint.
Okay. Mm-hmm.
So this is how it works. So yeah. Okay, so there's a multitude of services, and you need to combine. So it's often beneficial to combine multiple services together to approach your use case. So you're the user, right over here, right? So there are two things you're interacting with, right? You have two things with direct access to the two things, right? So right now we opened a separate service, which was the container service. So this was the Microsoft Azure blob storage, right? We uploaded our file, the yellow.csv.
Mm-hmm.
So this is up till here we are interacting, right? Up till here we are interacting with this. So this part is not our concern. This part is not our concern on the right hand side.
Okay.
So yeah. And then Azure Databricks we interacted. We created our coding notebook. So this is what we're interacting with. Now all of this is not our concern, right?
Mm-hmm.
So this is all happening in the background. The coding notebook will interact with the Databricks service, and the Databricks service will interact with the cluster we've created, right?
Yeah. Okay.
And depending on the instructions we're giving in the coding notebook, right? It will get compiled or parsed, whatever. It will go to Databricks. Databricks send that instruction to Spark and it's saying, take that data from Azure. Azure blob storage. Take that data from this location from blob storage. The information will be processed probably by the driver node, and it will basically ask the blob storage for that data. And since the permissions are granted, it's in the same resource group. There will be no permission issues. Blob storage will simply grant access to that data. and we'll get that data in our cluster. So the cluster will give that response back to Databricks, and Databricks will simply will get the output sort of thing that we get in every time we execute a code block in a Jupyter notebook. We get some sort of an output tab, right? So we get that post back instruction that yes, we've received the data. It's been loaded into an RDD or whatever we've created.
Where this logical workspace came into picture? What is its boundary? I didn't get that. For example, my question I can rephrase: can I have one workspace and many? Can I access many different storage container?
Yes, definitely.
Okay.
So this is just one instance of a blob storage.
Okay.
You can just have another blob storage on top of it that you can access separately, right? And you can access it with the coding notebook as well. It's as long as it is in the same resource group as our cluster, right?
Okay. That resource group binds everything together. Okay.
Yes. It is very essential that everything is in the same resource group. Otherwise, you have to do a lot of configuration to get past the authentication and everything. The data security is a very prime concern with these big organizations like Amazon, Facebook. So it's very essential that the permission thing is managed.
So then I would create more than one workspace, for example, for different clients, is it? Like, to give an example, one workspace I will create for one client, another. Am I talking in sense or?
No, it's not an issue. I think, say you're working as a data analyst, you're not working as a data scientist, right?
Okay.
So it may be the case that you will not have access particularly to the data scientist's workspace, but the data scientist could have the access to your workspace, right?
Okay.
So those are things that can be configured. And multiple workspaces are created. Say the data analyst workspace is there, so the only thing that the data analyst workspace will contain, you launch your workspace and you only are creating notebooks which are related to data analytics, not to machine learning, AI, or data science, right?
So this workspace is something for only for the code, is it?
Yes, exactly.
Okay. It's like any Eclipse workspace, something like that only.
Yeah.
Hopefully, yeah. Okay, yeah, you can go ahead.
Or you could go about this as well. There are various ways you can implement it. It depends on the organization entirely. Say the data analyst group contains all data scientists, data engineers, and everybody. So you create your cluster, right? You created the cluster similar to how we created the cluster. And the data scientist would create his own notebook. The data analyst would create his own notebook, but they are using the same cluster.
Okay.
That is also a way you can implement it. So that is more cost efficient.
How to do that? Okay.
Yeah. So the architecture is clear.
Yeah.
So we will now integrate. So this is a little bit tricky. So the first thing that we have to do is actually generate a token so that we can actually access this data for a particular amount of time in the same resource group, right? The container name and the storage name we don't have to worry about because we've already they're just string variables that are there in our. That I'll just show you in a moment. So I'll just paste this format over here. So this is something that you don't have to memorize. This is something that will be provided to you. Just copy this and paste it over here. So this is in the format of Scala. So we have to replace all of these things. Firstly, let us look at the container name, right? So now we are going to refer to the storage. Where's the storage?
We did something Databricks session, that one, right?
So open up the portal, go to the storage accounts, go to our recently created storage, and then we can simply go to containers and we have our Spark assignment. So this is the container name, right? We copy this, and we replace it over here. So we've created the variable. This is a string variable, a normal string variable, container name, and it has the name Spark assignment, right? The resource group also help us in the way that say if we are creating two resource group, there will be no name conflict. Somebody else working with me on the same Azure portal, organizational portal, is using the container name Spark assignment. We will not have a conflict because we are operating within different resource groups. I hope that's clear.
Okay.
Let's go back just a moment and look at the storage account name. So storage account name is just a moment. So we go back. So the storage account name is Databricks
Data
session storage.
session storage. Mhm.
Go back to the Jupyter notebook and replace the storage account name with that.
Mhm.
Right now, the SAS token. So this is the part where a little bit of technicality happens. So open it up, the session storage. Then we have to go to this shared access signature, this option that it is present in every storage account. Right?
Mhm.
So we go to that. And now we can generate a token for a limited amount of time. So it will not be valid forever. So say if I am accessing this data right now, if I'm able to do it right now, I will not be able to access it after the expiry time. So here we can set our expiry times, right?
Mhm.
Obviously for security reasons.
Okay. Till that
So
the
we
token
will,
is required.
yeah, that is that is the time that the token is valid. So we will allow the resource type, service, container, and object. And now we can simply generate our SAS token. So here we have our SAS token, right? Simply select that, copy all of it, and we can go back to our Jupyter notebook and paste it over here. So we have our SAS token right here. Just a moment.
So this is something very. It's only for Databricks, right?
Not so SAS tokens are these tokens are also, say if you're using another service that uses storage accounts and storage within them. So there might be a requirement for SAS tokens if you're directly accessing the data without actually. So these are all things. To avoid any sort of automatic script running, right?
Mm.
If you're doing it manually with the UI, it's all fine. But if you're running code, so that is where you need tokens involved, basically validity and some validity period involved with those tokens. So I think it should be fine, although I had a little bit of doubt with just a moment. Be fine. I think this token itself. So it's valid for 1 day. The start period is first and the end period is second of August. So yeah. All right. So I think it's fine. All right. So the rest of it remains the same, right? So it basically creates new variables, new string variables, where it's creating these links, right? By appending all of these strings together. So we have our URL, we have our configuration, right? And once we run this dbutils, now here is where dbutils comes in, because this is not something you would do in Spark or anywhere, right? So this is where Databricks comes in and tells you that, okay, if you're using cloud services, now we will help you get your data from some other service or some other storage place, right? So we've provided the source as URL, the mount point as /mnt staging. This is something you're creating, right? So you can use this address to basically assign to this particular storage container that we have. We are assigning this string to that. We are assigning this string to that storage container. So that whenever we use this string, we are actually referring to the storage container, right? You can put in anything over here, any string value that you want. And then we've specified the configurations. We've mapped the config with the SAS token that we've just created, right? So all of this is just to memorize, basically, and then not memorize, to basically copy paste.
It's like template code,
yeah. And then you press Shift plus Enter, and it'll the code will first refer to the first communicate with the cluster as we had shown in the diagram. It first communicates with Azure Databricks, and then it communicates with the cluster. The code executes on the cluster, and then once all of this is set up, we'll get our similar to how Jupyter Notebook works. We'll get our output message over here. So let us wait for that.
So you just executed only those 13 lines, is it?
Yes.
Just mounting. Okay.
So we're just attaching with the storage account.
Yeah.
And we're attaching to the container, not the storage account, to the container where we are having our file. So once we've done with that, then it becomes pretty simple. Then I think you will get into the territory where you remember what we're doing, where you're familiar with what we're doing. So the Spark, now it's running the command. There's one Spark job. So once that has finished executing, we have successfully assigned a particular address to our data container location. So we can see all of the details are there, right? And now we can start, right? So let me just look at the file name. I forgot. All right. So okay. So it's yellow.csv.
Yeah. That I remember.
Yeah. Okay. So create a val. So val is basically how it works in Python, except in Python you don't have to write anything before your variables, right? So you write val, and depending on the value that is assigned to a particular variable, it will change the data type as well. So exactly how it works in Python. And then you equate it to, now you will remember how this is something you might remember, spark.read. And then you give in the format. So the format right now is a CSV. And then you give in other options as well. You want the headers to be there. Then you given the option, because we're going to be implementing Spark SQL on it, we can essentially write this as well, the info schema, and we assign that as true as well. And for efficient data replication requirements, we will add the fail fast mode. Yeah. And then we give in the location. Now here is the part where the only thing you need to notice is this particular address, right? The mount point. We can use that. Copy this, paste it over here,
and put yellow as CSV.
Yeah, yellow.csv. So it should work now. Let's see. And then we press Shift plus Enter. There's an issue that we faced. Just a moment. Okay, just a moment.
Options? No, there is option or options. You have written options.
Oh, yeah, it's options. One place I have written options. That is a mistake. Yeah. So let's just change that. So one of the other advantages of using a notebook is that you can simply go over here and just remove this.
Yeah.
And you don't have to write it again. Appreciate the assist. Did not spot the S over there. So now we've created our data frame, right? So let us see that df.show and just limit that to 4.
Some 10. Yeah.
And
okay.
So let us just press Enter. So we have our data available to us. So it's quite big for the screen, so that is why it has shifted in that.
Yeah.
But it is there. So it is essentially some taxi job data, some taxi online taxi service data, where we have the pickup time and the drop off time, the passenger count, trip distance, and everything. So it's there. So
now you can manipulate using this data frame.
Yeah. So we can simply write something like everything is something like this. A df, we can create a temporary view out of it. Okay, this is something you might be familiar with. Temp view. So this is exclusively. This is now we are done with everything that is supposed to be about Databricks. Now it is simple coding. Now in Scala or in Python, in wherever you want to use. So let us just name this temp view. Not temp view. Let us name this taxi data. So we can refer to it by Spark SQL, and just press Enter, Shift plus Enter. So we've done that. You can also click on the play button instead of doing that, but that's obviously takes a lot of time. So say if we want to select, find out the number of rows, number of trips total, right? So we can just count the number of rows. So spark.sql, select, and then we're given the count. We got counting all, so we'll just give that from. And since we've named the temporary view as taxi data, we'll refer to that. And then we given the dot show. So we Shift plus Enter, and it will give us the information that we need. So it's about 10,000 records.
10,000 records are there. Okay.
Yeah. So similar to that, you can Spark SQL and write anything.
Yeah. Understood. Yeah.
So the reason I'm using Spark SQL is because you might not be familiar with the inbuilt Scala functions that are there. So Spark SQL gives us a common platform to communicate.
Yeah.
So now we can do something like, if we want to find out the total revenue that is generated by all of the trips, so we can do something like select sum, and then given the column name, let us look at the column name, total amount. Let us take that and put it over here. Total, I think it was underscore amount. Underscore.
Yeah. Total underscore.
So, and from
taxi
data dot show. So this is the total amount. Yeah. Just a moment. And all of this, if you want to simply say, now you want to write some data back into the storage service. So there's also another method for that. Since we've already created our mounting location, right? We can use this to also write back the data.
Okay.
right?
So it
So
will create a new file there.
yeah, so the way we do that is use this function, use this aggregate write mode, right? We simply copy this and paste it over here, right? So overwrite, if you initialize the overwrite mode, so if it has something with the same file name, it will overwrite that. So this is usually done. Say, what will you do when you have a routine procedure to follow, right? Say you want to constantly keep replacing the data that you have with new results, like on a daily basis. Say because the statistics change every day for your use case,
Yeah.
right?
Mhm.
So it'll if you don't write the overwrite over there, it will basically throw an error, right? Because the file name already exists. So
Yeah.
you have to put in the overwrite method. So it depends on the use case entirely,
Yes.
essentially.
Yes.
Or you could simply specify some counter, or and you can implement that in the string, concatenate it over here. The counter will increase, so file name should be different. You don't need to write overwrite, right? So if I
Yeah.
simply do that, and just a moment, the aggregate is not an actual. I think it's not the actual function. Uh, it's something for a default. We have to use over here. We have to use df, right? So once we've done that and put it something like df, that is not essential, by the way, but we're understanding it over there, and
Yeah.
shift plus enter. So if we just simply go back and
So
check
we
our
should be
storage
able
now.
to see in our storage. Yeah.
Yes, exactly.
Mm-hmm.
Was this one thing? Overview. We go to containers. We go to Spark assignment. So we have our output right here, right? So if we simply look at the folder structure, so it was up until MNT staging,
Yeah.
right?
Yeah.
This is what we mounted. So we created
Then it
another
is
folder.
created. Yeah. Yeah. Okay. In that
So
DFCS should be there now, right?
yeah, let's check that. So, yeah, so this is just
Okay. It has
it
created.
depends
Yeah.
on the file size essentially.
Yeah. 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 It's like Hadoop. I feel it's like Hadoop. This is a Hadoop
Because
on big.
generally Spark is used for big data cases, not for 1 MB
Yeah.
files,
Mm.
right? So when you have big files, they are divided into parts, right? So that is what you get essentially when you
Yeah.
put in the output. That was about, I think that was about it.